In yesterday class, we discussed about the phase. Phase means it is an angle made by the vibrating particle with respect to its mean position. It shows the particle's direction as well as its position. The position and direction, the phase shows the position and the direction of the vibrating particles at any instant of time. This is the phase. With respect to its mean position, it should be with respect to its mean position. It means the phase should be with respect to its mean position, called as the mean position of the particle. And if one particle starts to vibrate from its mean position like this, the one particle just starts to vibrate from its mean position here. If the particle at here or at here or at here, anything, different position. If it takes a new position at here, we have to show its direction. Its direction means, its position means, position with respect to mean position is like this. This is the position of the particle. It is nothing but the position vector. And its direction. Its direction is nothing but the phase, the phi. Phi is a phase here. The phase shows the position and direction of the vibrating particle with respect to its mean position. Okay, the next concept is here, that is phase difference. The phase difference of two particles. We have to difference in between the phase of two particles or phase angle of two particles. There are necessity of two particles there. The phase difference is nothing but it's a lack of harmony. It means it is continuously, if the particle is in a harmonic motion, if it is in harmonic motion, or it is a periodic motion is there, which is executing the harmonic motion, or which is considered or which is represented in terms of the harmonic functions sine and cosine. If the particle is moving like this, it means there is a lack of harmony. There is a harmony is just lost. It means this angle is just lost here. The lack of harmony of vibrating states of two vibrating particles. There is a state of two particles. Okay, at a given time, if you want any difference in the phase angle at a given time, that is we have to take at that time. Okay. Next here, the difference in the phase angle of two vibrating particles at a given instant of time is called the phase difference. It means phase angle between the two particles. Okay, the one particle is moving from its mean position like this with some phase called its phase as a phi 1. I will call that phase. Its phase is phi 1. And the second particle starts to vibrate from its mean position. Okay, the second particle is also there. Called the second particle starts to vibrate from its mean position. Like this. Whose phase angle, call that phase angle as a phi 2. That a phi 2, it is nothing, its angle should be in between what? The x-axis as well as its direction. Okay, it means the phase angle is represented with respect to what? Its mean position. It means the angle up to its mean position, at the mean position here. What is the phase difference of these two? If we want the phase difference, we have one equation for this phase. The phase of the first vibrating particle, phase of first vibrating particle is the phase of first vibrating particle called, that is the phi 1. Phi 1, we already know that one form for phase. That form is phi is the total phase, it is equals to the omega into t. Okay, it is phi into omega into t plus or minus, I'll take here plus of t, plus of what is that, phi naught, where phi naught is an initial phase. Okay, then the same phase, it is the phase of the first particle called, this is the phi 1 here. At that instant of time, okay, call this time as a t1. That omega is the angular frequency, it is constant, and this is t1 is the time taken, or it is a small instant of time for the first particle, and initial phase of every particle should be same. It is initial phase is nothing but what? At time t is equals to 0. That initial phase, it is called initial phase at t equal to 0. At t is equal to 0, the initial phase is 0, always same here. Okay. Okay, this is the first phase of the first particle, and second, the phase of the second vibrating particle. What happened? That become time taken, that instant of time is different because the phase is depends on the time only. Then its phase is phi 2 omega, it is constant, and it is t2 plus of initial phase is same. We want the difference in the phase angle of two vibrating particles. According to the definition of the phase difference, okay, according to the definition, what happened? The difference in the phase, yes, the difference in the phase is nothing but the phase difference, that is phi 2 minus of phi 1. Take here phi 2 minus of phi 1, or phi 1 minus phi 2. It should be plus, okay, it should be more, plus positive. Okay, next here omega into t2 plus of phi naught, difference minus the signs of eastern become change here, omega into t1 minus of phi naught, these two gets cancelled, and omega is common here, omega is common into t2 minus of t1, and it is what, phi 2 minus of phi 1. Okay, next is, it is nothing but what, the difference in the phase of two vibrating particles, called this is as a delta phi, or it is equals to what, omega, or equal to, and or it is nothing but what, the difference in the time, instant of time is there, call this is a delta t, delta t. One equation, this is called the phase difference. Also we have the angular frequency. That angular frequency omega is equal to what, 2 pi divided by t, 2 pi divided by t for one revolution. Okay, here n is equal to 1 for one revolution. Then substitute here, delta phi is equal to 2 pi divided by t into delta t. It is the phase difference between the two vibrating particles. I already written one formula, that is we have to calculating the path difference, phase difference, and also time difference. I written that formula. Here it is a phase difference divided by 2 pi. It is equals to what, time difference. I written one formula. Just I remember here, we have one formula, the phase difference delta phi divided by 2 pi, which is equals to path difference. I won't take here the path difference, just I'll take that time difference here. Then here time difference, that is delta t divided by time period for one revolution, that is t. Just take here the phase difference. Phase difference is delta phi, it is equal to 2 pi, become the numerator of RHS here, the 2 pi into delta t divided by t, it is nothing but the same form. Okay, the same form is there. Yes, this is the phase difference between the two vibrating particles. Afterwards, if the two particles are in phase or out of phase, or a same phase or opposite phase, how can we calculate that? Say the two particles are same phase or those are opposite phase. Okay. First one, if two particles are in same phase, I will write here the two particles are in same phase. I will draw only one diagram for that. If two particles are there and both are in same phase, okay, I will draw the only one part. Okay, if one body or one particle starts to vibrate from its mean position, whose displacement called this is y, and is the negative displacement of the particle, that is minus y, it is called the mean position of the body, it is called the time axis, which is along x-axis. If one body starts to vibrate from its mean position, like this, if one particle starts to vibrate from its mean position, whose phase call this is phi 1, okay, or it is only phi 1. We have to calculate the phase difference between the two particles if those two are in same phase. What happened? What is the path difference? What is the time difference? And what is the phase difference of those two? Okay. Here, to complete one period, it takes the total time is t here. The total time is t to complete the one period. From here it takes the 2t. From after that, that is here it takes what 2t time from its second period starts when the after the second period starts here. Okay. Next is the what is the angle? What is the angle here? If at mean position that omega t is equals to 0 here. Okay, omega t is 0. Next is at here it is pi by 2, and to complete half period means if it is a mean position of the body, it starts to vibrate from like this. Only like this, it means what? Its angle is 180 degree here. Up to here it is 180. 180 means it is a pi. After it returns back, it covers what? Another 180 means 360 degree. When it completes the total one period, it takes the total angle is 2 pi. And the time period at here it is t by 2. Okay. And at the time taken, the time period to complete one revolution is nothing but the t here. After that the second period starts. Here consider this is the t is t as a t here. Okay. Next, at here it is t by 2. It is 3t by 2. Okay. Next, last bit is 2t. Okay. That's so. I'll take here, if those two particles are in same phase, means if it is a positive, if it is positive, it starts from its mean position. It is considered as a positive displacement of the body. It is positive, it is considered as a positive displacement of the body. And it is nothing but what? It is opposite to this one. This considered as it is a crest and it is a trough. This trough is opposite to that. It is a negative displacement. It is a positive displacement. Those two are opposite phase. When the when trough starts from t by 2, it means these two are in opposite phase, in opposite direction. Okay. Next, the same phase means what? It starts from its mean position in the positive direction, and after t, it is travel in a positive direction, considered as a mean position. And it is a phase, this is the same phase, this is one phase, this is the same one phase, both are in a positive direction, so considered as a same phase here. These two are in same phase, these two are in same phase, these two are in opposite phase, these two are in opposite phase here. Okay, then same phase, right here the same phase starts from what? First initially it is 0, starts from 0 here. Then after that it is t, then if the next period starts here, then that become what? 2t, after 2t. It means after 2t means here 2t is completed, 2t starts here. Then it is 2t, then again it is so. Then now tell me the time difference of this wave is 0 into t. 0, 1, 2, 3, 4, 5, 6 up to n. It is n times of what? The time difference. N times of time difference. Okay, it is an integral multiple of the total time period. Integral multiple of time period of one revolution. Then, if two are same phase, from here, the time difference both of those two. Okay. The time difference. Sorry, I want to calculate the phase difference here. The phase difference of two vibrating particles. I take here only one particle. One starts from its here, one starts from here. Consider as that one starts from here, another one starts from here. Okay, and I'll draw here only one line. Okay, next here. The formula for the phase difference is delta phi is equals to 2 pi divided by t. 2 pi divided by t into delta, it is small t, into delta t. This is the time difference, the total time difference. The time should be, we have to take the time period should be here. It is total time up to here at this instant of time. We have to calculate it at this instant of time, this instant of time here. First, we have to take at initial 0t, at t is equals to 0, at t is equals to, or the time difference, at the delta t is equal to 0. If the delta t is equal to 0 means at here. At here, what happened? The phase difference. Write the phase difference that the delta phi is equals to the 2 pi into t into 0. Then what happened? The phase difference is 0. Okay. If the phase difference is 0 here, it is starts from its main position. Okay. The next part is here. The phase difference. I want to write here the phase difference. Next, at in same phase means at delta t. Delta t is equals to what? It starts from here. The same phase starts from the t here. Then 1t. 1t means t. At t is equal delta t is equals to t. Delta phi is equal to what happened? 2 pi divided by t into t. Then these two gets cancelled. Next, the delta phi is equal to what happened? Delta phi is equals to 2 pi. Initially it is 0. Next it become 2 pi. Next, and delta t is equals to same phase means same phase again same phase. Next it is 2 pi. Sorry, it is 2t. It is 2t. Delta phi become 2 pi divided by t into delta t is equal to how much? 2t. Then 1t gets cancelled. 2 into 2 it is a 4. Then here the delta phi is equals to 4 pi. Okay, 4 pi. Similarly, the remaining phase is here. The remaining phase at t is equals to 3t, 4t, and again here the 5t continuously. And here similarly delta phi is equal to what happened? 4 pi. After that it is 6 pi, then 8 pi, then 10 pi, so on. Okay, right here, then I will calculate another one. I will calculate here another one. If at t is equals to, at delta t is equal to, delta t is equals to, after that 3t is there, 3 times of t. Then delta phi is equals to, delta phi is equals to 2 pi divided by t into delta t is equal to how much? 3t. Then it is 3 times of t. T gets cancelled. Again here delta phi it become 6 pi. It is nothing but the phase difference. The phase difference of two vibrating particles. The delta, it is here, the phase difference of two vibrating particles in same phase. Same phase is and integral multiple of something, anything. I will write here. I will write first here, after that I will continue the sentence here. First one, delta phi is equals to initially 0. Then after that it become 2 pi. After that it become 4 pi. After that it become 6 pi. So on. Finally it become what? It is 1 pi, 2 pi, 4 pi. Sorry, it is 0 pi. 0 pi, 2 pi, 4 pi, 6 pi. All are the even numbers here. All are the even numbers. Means here it is nothing but 2n pi, 2 times of n into pi. It is nothing but an even integral multiple of pi. Okay. The phi is nothing but, delta phi is nothing but what? It is nothing but, it is an even integral multiple of phi. One sentence is over. Then what about the time difference? What about the time difference here? The time difference, is whatever. 0, 1t, 2t, 3t, all are there. Okay? The time difference is here and integral multiple of only integral multiple of time period or one time period. Integral multiple of time period or t, or it is known as t. It means what? The time difference delta t is equal to what happened? 0, t, 2t, 2t, then so on. When in same phase, then again the path difference of two vibrating particles. The path difference of two vibrating particles in same phase is what happened? The path difference is nothing but what? The delta x. Okay, delta x is equal to what happened? It is nothing but 2 pi divided by path difference is there. We have to take the path difference here. Calculate. It is nothing but what? The time difference is there. Path difference. The path formula is delta x divided by lambda is equals to delta t. Okay, lambda into delta t divided by t is here. The form is there. Already right? Delta x is equals to lambda into delta t divided by t using yesterday's formula. The lambda is in the denominator of LHS, it becomes a numerator of that. Okay? And become what? Lambda into delta t divided by t. If you write the value of all these things, what happened? It is again pi is also there. Here 2 pi is there. Again, if you calculated this one, what happened? The same form is there. The same form, the phase difference is also an integral multiple of lambda or the full wavelength. How can we calculate here? If delta t is equal to 0, lambda is completely 0, then delta x equal to what happened? 0. If delta t is equal to t, t gets cancelled. Delta x equal to how much? Lambda, 1 time, 1 is there. Then delta t is equal to 2t. Then what happened? Delta x is equal to t gets cancelled, 2 lambda. See here, time difference is an integral multiple of directly one time period. Same again. Okay. Yes. This is nothing but what? The same phase. In next class, we'll discuss about the opposite phase. Like this, when those two are in opposite direction. Okay, thank you.